Hey guys, this is 1-3 solving equations. Today, for the first part, we are going to do examples 1, 2, 3, and 4. 1 and 2 are primarily review. 3 is something you've seen before, but probably not something you're 100% comfortable with. And then example 4 is going to be brand spanking new to you. Well, most of you anyway. All right, so without any further ado, let's go ahead and get started. All right, so for example 1, we have solving an equation with a variable on both sides. So again, not bad. This means that we need to get the variables on one side, the constants on the other. There is no right or wrong answer here as far as do you start with your numbers or do you start with the variables? Do you move the variable or do you move the constant? Variable goes on the right, variable goes on the left, so it doesn't matter. So the main thing is you pick a side, you pick a term, and then you work from there. So I'm going to choose to leave 7x on the left, which means that I need to get rid of any x term on the right. Getting rid of is the same as undoing the inverse operation. So the opposite of 2x is to subtract 2x. So we're going to subtract 2x from both sides. Ooh, sorry about that. And this leaves us with 5x plus 3 equals negative 12. All right, now that we have the variable on the left, that means I want the constants on the right. So I need to get rid of, undo this 3. I'm going to do that by subtracting 3. That leaves me with 5x equals negative 15. We're going to divide both sides by 5. And that's going to leave us with x equals negative 3. And that's it. That's all she wrote. In order to check your answer, what you might want to do is plug your value for x into the equations and double check and make sure that the left side does, in fact, match, equal the right side. Okay, so let's go ahead and do example 2 using the distributive property. And so now for this one, we are going to have to distribute that 4 and that negative 3 before we can start looking at moving things around. Right, so I'm going to distribute this 4, giving us 4m plus 36, distributing this negative 3. I better put that equal sign before I forget. Negative 3m, and then negative 3 times negative 4 is positive 12. So just like we did on example 1, we now need to decide where do we want the variables and where do we want the constants. Sorry, I'm going to leave my variable on the left side again, just because no purpose. So that means I need to undo this negative 3m. The opposite is a positive 3m. So we're going to add 3m to both sides, giving us 7m on the left plus 36 equals, these two terms cancel out and you have 12. Since we're leaving the variable on the left, that means I need to undo this 36. I need to subtract 36. And what I do to the left, I have to do to the right. This gives us 7m equals negative 24. And now we divide both sides by 7. And that leaves us with m is negative 24 over 7. Oh, almost forgot to write over 7. All right, and that is not a perfect divisible value, right? And we could write it as a mixed fraction or as a decimal, but it's actually in your best interest to go ahead and leave it as an improper fraction because you don't know if you might need it for something else later. Just trust me when it comes to your science classes. All right, so now let's go ahead and take a look at example 3. And example 3 is rewriting formulas. We've done this since pre-algebra, maybe even earlier, but I think because there are so many different variables in there, so many different letters, it tends to be a little bit intimidating, especially when you look at the one for your notes. The formula for the surface area of a rectangular prism is A equals 2 times the expression LW plus LH plus WH, and then solve the formula for W. So I need to solve this formula for W. I need to have the W by itself. Well, the first thing I want to do then is identify where my W's are, so I know where I should begin looking. Okay, that means this expression needs to be isolated so that I can get to these terms. Well, right now we're multiplying that whole expression by 2, which means the best thing that we can do is undo that 2. The opposite of multiplying 2 is to divide by 2. And if I write it over here so that you can see it, if I have divide by 2, that's the same as divide by 2 over 1, right? Well, I know when I divide a fraction, I actually multiply it by the reciprocal. So I'm going to multiply both sides by 1/2, right? And so those 2's are going to cancel, and we have 1/2 A equals LW plus LH plus WH. Still need to keep my eye on the ball. We need to solve this equation, this formula for W. So we need to get the terms with the W alone. That means I need to get rid of this term. So we're going to subtract LH from both sides. And that leaves us with 1/2 A minus LH equals LW plus WH. All right, so now that we've completed that step, it's a good idea to refocus. We're solving this formula for W. So that means I need to get W by itself. Well, we're multiplying W to the L, and we're multiplying W to the H. And then we're adding those two terms together. So let's factor that W out. And factoring is similar to division, but it isn't a process where it goes into it evenly. You're just pulling it out, and it's still visible. It's still part of the expression or the equation. It's just being factored out of the terms that you have within the parentheses. So factoring out this W leaves an L, plus factoring out a W here leaves an H, sorry. And then we still have 1/2 A minus LH on the left. Okay, so I want to solve this for W, and right now we're multiplying this expression to W. So the opposite is to divide both sides by L plus H. That cancels on the right, and your final answer, W equals 1/2 A minus LH all over L plus H. I know, it can be scary, it can be intimidating, but the truth of the matter is you can do it. You do it all the time when you have numbers. So if you need to put a number in just to substitute that in to help you, then by all means do that. But just take it in the steps that you would if you were working out with numbers. Okay, example 4 is the brand spanking new one that can be very tough to understand for some. And the part that's the hard part, really, in my opinion, is this find any restrictions on A and B. Okay, if you have to find a restriction, that means you need to look and see if the original equation had a fraction with a variable in the denominator, and if the concluding equation has a fraction with a variable in the denominator. All right, so looking over here, we have solve x over a plus 8 equals b, and we want to solve that for x. So I need to get this x term alone. Well, we can go about that 2 different ways. I don't really much care for the fraction there. I know I need to get the x by itself, so why don't we go ahead and multiply each term by an a? That means the a's on that first term cancel out, and you have x plus 8a equals ab. We're going to subtract 8a from both sides because I want to isolate the x, and that gives us x, that cancels out, equals ab minus 8a. All right, so now looking at the finished equation, I don't have any fractions, so I don't have to worry about whether or not there's a restriction. But when I look up here at the original, I notice that I do have a fraction and I do have a variable in the denominator. So what you do is you take whatever is in the denominator. It doesn't matter if it's an expression, uh, if it's just a variable, if it's a variable with a coefficient, you are going to take that denominator and write a does not equal 0 and solve it for the variable, in this case the a. Well, it's already solved, so the restriction is a cannot equal 0. And that makes sense because if you go back up here and you had a 0 in for a, then that would be an undefined equation. You cannot have a 0 in the denominator. So the final answer, x equals ab minus 8a, with the restriction that a cannot equal 0. All right, that's it for the first part, guys. I hope this has made sense, and if not, please feel free to shoot me an email, and I'll be more than happy to help you out. Have a great one.